In this video, it's gonna be pretty short compared to what I usually to the kind of length that I usually upload. This is just to answer a certain question. This is an example of a trig equation, and yeah, I intend to answer it. So first things first, what I want to do, given this kind of equation, is to turn it into, well, basically rewrite it in the form ax raised to 2 plus bx plus c is equal to 0. So how do we do that? Well, as you can see here, we have sine thetas. We'll group them together in one side. So transpose 3 sine theta from the right side, move it to the left, and transpose the, well, no, we don't have to transpose the 1. We'll just keep it also in the left side, and we place a 0 in the right side. So what's next? We're going to let a equal to sine theta. And just another detail that you'd want to know is that, sine theta, sine raised to 2 theta is also equal to sine theta raised to 2. So from there, we can say that it is also equal to a raised to 2. You see the resemblance? The only difference is that this is only raised to 1. This is raised to 2. So next is we substitute. And then we turn it into factored form, and we put them into different situations, because we know that we'll be having 2 a's. Now, we're not done yet. So far, we have identified the a values. Now, we'll bring back sine theta instead of a. So sine theta is equal to 1/2, and then sine theta is equal to 1. So we're going to have left and right sides. Now, here, angle theta is equal to arc sine of 1/2. For the other side, we'll be having arc sine of 1. So let's deal with the left side first. So we all know that based on the ASTC principle, well, don't cite me for calling certain formal terms, because it's definitely not formal. I don't know what's this exactly called, but it's useful. So imagine this is a Cartesian plane, and this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, all are positive. In quadrant 2, only sine or s is positive. In quadrant 3, only tangent or tan is positive. And in quadrant 4, only cosine or cos is positive. That is C. So sine theta is only positive where? In which quadrants? We need to identify the quadrants where it is positive in. What are they? Definitely just not just the one quadrant. Well, here for quadrant 1, everything is positive, so that's one of them. What else? Well, it says here s or sine is only positive, so we also have quadrant 2. But for 3 and 4, they are not. Sine is not positive in those quadrants. And one thing that we also have to know is that sine theta is, well, generally based on the term soka towa, sine is O over h. And we know that sine theta is 1/2, right? So the 1/2 here, it's going, well, the 1 is going to correspond to opposite and 2 to hypotenuse. Now, let's bring out two triangles. The other, well, these are just basically called special triangles. One of them is 45, 45, 90. Oh no. And the other one is a 30, 60, 90. In a 45, 45, 90, the opposite sides of the 45-degree angles, they're basically equal to each other. We have xx. And for the side just opposite of the right angle, we have x square root of 2. For 30 degrees, it's x. For 60 degrees, what's opposite of it is x times square root of 3. And then what's opposite of the 90 degrees is, I think, 2x. Am I correct? Well, yes, I am. Okay. But at this point, we don't really have to put the x's anymore. We can just put 1. Okay. So, looking at these two triangles, which angle do you think would give us which angle would match with an opposite side of 1 and a hypotenuse of 2? Definitely not this triangle, because with our hypotenuse it's 2, and the sides, none of them are 2. So definitely the answer that we're looking for is in this triangle, the 30, 60, 90. Now what do we have to look for here? Well, why is this definitely the triangle that we have to examine? Well, we have 1 and 2. This triangle has sides 1 and 2 also. So what do we do now? Well, basically, we identify. The hypotenuse is 2. So that's a given. We just have to determine whether it's 30 degrees or 60 degrees. What is the opposite of 30 degrees? That's 1. So it's supposedly a match with this. What is the opposite of 60 degrees? It's square root of 3. It is not, well, our opposite is not equal to square root of 3. It is equal to 1. So our angle is 30 degrees. That is our reference angle. How about the, well, let's start graphing now. Okay, so we have 30 degrees. Again, the quadrants that we are going to draw are 1 and 2, because those are the only quadrants where sine is positive. So we draw something like this. And then, well, we also have different data for quadrants 1 and 2. This is for quadrant 1. This one is for quadrant 2. Regardless of quadrant, the reference angle remains the same. So for quadrant 2, the reference angle data is also 30 degrees. How about the standard angle? What is a standard angle anyways in the first place? Well, I can't really give an exact definition. However, I can describe it based on certain properties. So at least for quadrant 1, well, strictly only in quadrant 1, the reference angle and standard angle are equal to each other. That is only true in quadrant 1. If it's quadrant 2, 3, or 4, well, it's a different story, and I will explain soon. So, this is what we have right now. I'll just duplicate this. So for quadrant 1, this part, again, the ref angle is equal to the standard angle. So that's the data for quadrant 1. How about for quadrant 2? By the way, for quadrant 1, this is the standard angle. For quadrant 2, it's like that. So if you notice, this is 180 and this is 30. So 180 minus 30, it's 150 degrees. Okay. Now, well, we already have these standard angles. Now we look for, let's focus on the right side this time. So just to let you know, there is something called quadrantal angles. And basically, there are only 4 possible answers for quadrantal angles. We have 1, -1, 0, and undefined. If you happen to have any of these 4, then definitely we're dealing with quadrantal angles, such as in our own example. What's inside the parenthesis is a value of 1, so definitely it's associated with quadrantal angles. Well, now, what do we do? Well, in order to solve this, we'll draw a Cartesian plane, just for reference. And we have something like this. So this is 1, 0. This one is 0, 1. This one is -1, 0. This one is 0, -1. So, what do we have to look here? What do we have to look for here? Well, we need to look for a coordinate among these 4 that has a y coordinate of 1. So by default, this is the standard format, x in the left side, y on the right side. We need a y that's equal to 1. And the only thing that gives us that is this one. So, moving forward, if this is our standard, well, we have to measure the angle going there. So from here to here, it's a full 90 degrees. Therefore, that's our answer. So the angle for arc sine of 1 is 90 degrees. Okay, now, what is the final answer? By the way, well, never mind. So what's this final answer? We write it in a solution set. So SS theta is equal to all of the following. We have 30, we have the 90, and we have the 150. This is the final answer. I feel like I still want to answer another question. I think I do. Yeah, let's actually solve another one. I should have written the question before starting the vid, but anyways, you can just skip this part. We'll eventually get to the solving part. Right now I'm just copying. Again, feel free to skip this part. Okay, so what do we do here? Well, of course, we have to simplify this. We don't have to turn sine theta into a. We don't have a raised to 2. We don't have to factor in any way. So yeah, we just simplify. Transpose sine theta from the right side to the left, and then this time we don't need to write the equation in this default formula format. We can just transpose positive 1 to the right side, which gives us negative 1 in the right side. The positive 1 is in the left side. 2 sine theta is equal to negative 1. Sine theta is equal to negative 1/2. And from there, we put an arc sine. So, we from here, we can notice certain observations. So, first things first, the sine value here, the fraction, is a negative. So, where is sine negative in? Based on the Cartesian plane. Quadrant 1, everything is positive. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. So definitely these two quadrants basically state that sine is a negative. So in terms of quadrants, we have quadrant 3 and quadrant 4. How about the reference angle? Well, we'll get to that. But right now, we know that the fraction is comparable to this. So O and then H. Again, let's use the special triangles. We need reference. Okay, reference angle. Now, if we have sine, what will give us 1 and 2? Well, of course, it's not going to be 45, 45, 90, because among all of the sides that it has, there is no 2. This is not equal to 2. So, goodbye again, 45, 45, 90. Let's use the 30, 60, 90 again. So definitely, what is the angle? Is it this or this? But similar to our previous question, we also have a fraction 1/2. So naturally, it's supposed to be the same degree value, which is 30 degrees. So we have identified the reference angle. But what we're dealing with is quadrants 3 and 4. So definitely the standard angle isn't equal to the reference angle. But we will find them out eventually. Okay, let's draw again. Now that we know that the reference angle is 30 degrees, 30 degrees, 30 degrees. I'm sorry if it's not symmetrical. It was intended to be symmetrical. But yeah, it's not drawn to scale, I guess. So, what's next? We look for the standard angle. So for the standard angle corresponding to quadrant 3, we have, so starting from here, we have angles there. So here, we have 180, but plus 30, that is 210 degrees. For quadrant 4, if you go beyond, over there, we'll measure, well, this is 270, the one over here, and this is 360. what we have here is 30. So 360 minus 30 is 330 degrees. Oops. I'll just keep that there. But anyways, we already found the two standard angle values, 210 degrees and 330 degrees. And actually, we already found the answer. So for the solution set, theta is equal to the following. We have 210 degrees and 330 degrees. Okay, that's the final answer. Okay, that's it for this video. Actually, I just learned this a few minutes ago. Definitely the answers are correct. I hope my explanation is also correct, which I'm most likely sure of. And yeah, that's it. Thanks for watching.